What's up everyone, it's Red Saber here from Saber C++, and today we're adding the finishing touches to our Tetris game, including score, a game over screen, a pre-screen, and sound. We're going to need a couple of functions to help us draw text on the screen. The first one will be void draw string, and we'll need a string text, an int x, an int y, an int size, a uint16_t color, and a uint16_t background color. First, we'll run aboy.setCursor x, y, then aboy.setTextColor, color, aboy.setTextSize, size, aboy.setTextWrap, true, aboy.println, text, and aboy.display. Basically, we're just taking all of the things we need to do and combining them into a function so we can write one line instead of 6 each time we need to print something. Then we'll need to create a void drawCenteredString, and this will draw a string in the center of the screen using a string text, an int y, an int size, and a uint16_t color. First, we'll find the length of the text in pixels by setting int length equal to text.length times 6 times the size. Then we'll calculate where the left side of the text should be by subtracting length from 128 and dividing that by 2. If left is less than 0, we'll want to set left to 0 so we don't go off the screen. The last thing to do is run drawString text left y size color black. So we use the drawString function that we just created to draw our centered string at the correct position. Now in the main loop, instead of printing out the score in the serial monitor, we can run drawCenteredString string score 56 1 white to draw the score as a string underneath the game field at y position 56, and of course we're using text size 1 and color white. And instead of printing out game over to the serial monitor, we can run drawCenteredString game over 26 2 white to make nice big letters in the center of the screen, and drawCenteredString string score 56 1 white, same as above, so that we can draw the score below the game over sign. Then we can create a void pre-screen below the setup function, and inside it we'll use drawCenteredString to print Tetris at y equals 26, size 2, and color white. And then I'm going to print out by Red Saber, except you can put whatever your name is there because you created this. I'll put it at position 56, size 1, and color white. Then we want to delay for 1000 milliseconds or however long you want the pre-screen to show up. I'll call this in the setup function after we boot up the aboy, and then after it I'll run aboy.clear to remove it before we start the game. Let's try it out. As you can see, we now show this cool pre-screen before playing. The score shows up while we're playing, and if we fill up the field, the game shows us game over the top of the field, and we still see our score down at the bottom. Let's add some sound to improve the player experience, and then our Tetris game will be complete. At the top, let's hash define speaker pin speaker 1, which is a keyword from the Arduboy library that holds the pin the speaker is on. Then in the setup function, after we boot up the aboy, we can run pin mode pin speaker 1 output and pin mode pin speaker 2 output to let the Arduino know that we're using the speaker. So when we place a piece right before we increase the score by 25, we can run tone speaker 1040. Speaker is of course the pin we're running it on, the 1000 is the pitch, and the 40 is how long to play the sound. Then we need to delay for 40 milliseconds before we play the next sound because otherwise it will remove the first sound, even though it's supposed to be playing for 40 milliseconds. I'll once again run tone with speaker, then I'll change the pitch to 1250 and the time to 20, and delay for 20 to run a higher tone for an even shorter time. Then when the player completes a line, let's create a for loop with an int I set to 0, continuing while I is less than 1000, where I plus equals 100 each loop. Inside the loop, let's run tone speaker I 50 and delay 50. So we'll play a tone at 0 for 50 milliseconds, then at 100, 200, and so on, all the way up to 1000 to give us a nice rising music rate. The last thing I'll do is add a bit of sound to the pre-screen. So we'll create a for loop going from 0 to 7, and inside of it we'll tone speaker I times 100, 10 times I, and delay 10 times I. This will play increasingly high notes, but it will also play them for slightly increased lengths of time. Then we'll add a tone speaker 750, 40, and delay 40, and a tone speaker 580 and delay for 80. Of course, this is just what I'm doing to add some sound and a little more life to the game. I highly recommend you try out using some different sounds and pitches, especially with for loops, as they can be quite fun to create your own interesting sound effects. As you can see and even hear, the game now feels quite complete and professional. Well done! Hit the subscribe button so you don't miss the other awesome Arduino projects we have coming up, and if you want to make another MicroCade game, check out the video on the right.